Hello, sir. So today I'll be taking you through my final project. So this is the alphabet detection project where I'm trying to use imaging to identify hand patterns on someone's hand. So currently on my screen, you can see that I have some code running. So coming up with this project, one of the issues I faced was getting data. So I was able to get data, but the standards I was looking for wasn't the best, and they were in huge sums of like in terms of the size, and that became difficult to train considering the kind of resource I had. I'm using the Dell E7450, and doesn't have a GPU. And it's really restricted in a number of ways, but I still came up with some innovative ways. I'm going to take you out through what I did. So because I was having issues with finding good data and reliable one, I decided to create my own data. And in doing this, I had to learn sign language because I didn't actually know sign language. So as you can see, this is my README file. I used this library where I was able to now see some signs and try and process it. After learning it, I passed it by the Access Sign Language Club where I got some review on it. So the initial plan was to be able to sign up to Z, but due to time constraint and projects at this time, like I mean prayers on other courses, I was still able to reach from A to K. And from review from the Sign Language Club, I didn't sign alphabets like J, and also I think there were two alphabets. So I felt like, yeah, I have it here. I couldn't sign alphabets like J specifically, and yeah, and H, because these alphabets were actually ones which included hand movements. And looking at my results, I couldn't take in video feeds to be able to detect. It would have been a good project. I think I'm going to add it to the future works on this project. But yeah, so let's see how I start taking data. So to start taking my data, I incorporated a library which is media pipes, which has actually been already built in Python, and it's able to detect your hand. So I'm already in one of my folders. I had to do a number of projects to come up with the best approach in doing this. So the first one I did was to incorporate this media pipes where I'm actually um trying to detect my hands and put landmarks. So landmarks are like key points, which is able to identify my palm and normalize it. So whenever I'm really moving the finger, you should be able to still identify it. So you can see me on my screen now. So I'm going to try and understand my hand movements. Yeah. So you can see it. So the red colors you're seeing there are key points, which have been landmarked on specific parts of my hands. So as I move it, it's still able to like normalize it. So but it stopped. It stopped because in my data, I decided to have 100 frame of pictures taken in seconds. So what that helped me to do was to maybe come up with a hand sign like this. So this hand sign, let me use this. So this hand sign here, I think is maybe a big show. The hand sign here is okay. So it's F E F. Okay. So this hand sign here is E. So what happens on like from the code when to initialize it, you just click on kill and it's going to like detect it, and I move it all around. I'm moving all around because I wanted to normalize movements from other people. So it helps me to take 100 different frames of the same sign. And this has been saved in a folder which will later be used. Let me count this. So I did this for all the alphabets to K. And what happens here is that now I took this data and I went to train it using NLP. Let's say NLP, so I mean using convolutional network. So let me take you to the code. Okay, yeah. So it was a little challenging here, I have to say, because in trying to understand the huge size of data, if you look here, I tried maximizing I tried by maximizing the number of sizes because looking at my instances, I was taking I think initially I was taking 200 images per sign. which this include different angles of me taking that sign. And I was thinking I could leverage Google Colab in doing this, but I had a very hard time in getting it finished under like training and getting good accuracies. And yeah, so this was some of the testing I did. It took like 3 hours and it wasn't still giving any good results. And this became really challenging because of how I was getting I was losing my runtime in respect to the CPU assigned to me on my Google Colab account. So in trying to find out other ways, I then had to review my work and I thought why not I focus more on understanding key the key points. The key points are basically the landmarks I spoke about. And the idea here was why don't I now save rather the plots of these key points and now make them into an array. So I'm going to like normalize it into an array. So let me take you to that part of my code. So if one more explanation, I have a very extensive with me, I think, which actually covers some of them. But I'm just going to try and keep this video short. So yeah, let's go to folder called create data sets. So create data set folder basically hosts our data library where we have all the images saved, the images taken. So this is not an image I took during this video. So you know what, let me just find one I took during this video so you can see that it's actually saving it. I took this current images in my final work data test. So you can see. So that's it. So it takes a data like this and it passes it through this file in here. And what happens here is that it's just going to find the X and Y markings. So it has a plot for it. And luckily for me, the media pipe actually has a function which helps me to like extract these plottings. And now the main focus here won't be understanding the hand features in creating a sign, but now we'll be trying to figure out the plottings for me creating or trying to sign an alphabet. So now it gets this plotting for all the key points on my fingers and now sees it for me and labeling it in another folder here. It's called pickle data. So what I'm showing here is just me trying to cram all the signs and put it all in one pickles data. But what I evolved in doing and doing this part of the work was that I decided to save every sign in its different pickle folder. So to explain what I'm saying, let's go to test work 2, where I also took some data here. And what I did here was that each sign should have its own pickle data. I did this because I realized that I was losing some of the features. It wasn't saving everything in my pickle file. I'm yet to understand why, but to be able to get all the size, that's 100 for per 100 frames per second. Okay, not per second, but 100 frames per the number of images taken. I needed to save each data set's key points as an array in here. So let's go back to the code. I think yeah, go to the code and create data set. Yeah, so I was saying it saves as an array, it saves the X and Y values, and now it's been saved in here. So now I have my new data set, which is more on the keynotes. So in my main work, I have it here. So you can see here that I intentionally saved each feature with their names to help me label it when I'm training. So let's look at how I went about it. So because I was now dealing with numbers, I made my training much simpler and not that difficult. So I decided to go with using random forest. So this is me trying to get my data here. So what happens here is that it now goes and fetch all the so I had a folder which had all the pickle points I got from extracting the key points, and it got all the data and aligned it nicely for me, classifying it and giving it the labels. So this is me trying to see all the signs I did. So you can see I have their classification for it 701 here. So then I pass it into the I actually label encoded it, yes. So I can be able to get good extraction and understanding for the data for my training. So after training it, looking at the configuration matrix, it actually gave me a good result, showing that I was able to actually identify all the key patterns for each class. And this gave me 100% accuracy, which was looking really outrageous. Because I don't know, I feel like it would have maybe given a good model, but not exactly 100% though. But this model actually did work well. So let me take you back to my code. So yeah. So to be able to test it, we are going to go to uh, UI. Um, this is a file called image classifier. So this is where you actually classify to see if the model is actually given good accuracies or not. I think one limitation to I realized too was that image quality. The camera frames my laptop was given wasn't always the best. So you have to like sometimes adjust the camera so it can fully identify your hands. So I think in further research on this project, I think whoever wants to take it up, I'm sure I'm going to continue like taking it up. Okay, yeah, it is. Um, the person will have to try and get a good quality. So you can see this is A. I need to come closer. Let me adjust my screen. Yeah, so you can see it's identify that this is the A. So B, let me move my image here so I can just confirm. So this is B. So you can see that identify B. Let's do C. So that's C. Let's do D. So sorry, my this one crashed. Let me try running it again. So as I said, which those constraints here. But I'm happy about this because at least it shows that just focusing on key points gotten from my data would help me identify means yeah, so that's H. So you can see that I'm trying to sign H. Yeah. Please read. I would like you to read more on this project and in my README file so that you can gain more interest and insights. I'm looking to continue this project. The plan is to build more data, classifying for the whole alphabet, and I'll try and reach out to the sign language club and see how we can make this project better and possibly even add image recognition, which will make it more robust in the future. Um, thank you very much. Let me end this.